Sometimes groups of people or organizations or clubs have their own lingo, and you have to know that lingo or at least understand it if you want to really appreciate what's being said. Well, in the world of IPv4, there is definitely some lingo regarding the IP addressing, and I want to take a few minutes with you in this nugget and just take a look at some of those concepts and terms. And that way, if you and I are reading something or talking with other people, and they mention a term like octets or a 24-bit boundary, we'll understand more clearly what they're talking about. And to start us off on a really good, solid foundation, let's imagine that we're visiting a computer. It could be this one or this one. And we're looking at the properties of its IPv4 configuration on the network interface card. Or we've done ipconfig at the command line, and the computer shows us that the IP address is 10.1.0.37. Let's also imagine it showing us that there's an associated mask of 255.255.255.0. Now, from previous nuggets, we've identified that an IPv4 address has 4 numbers separated by 3 periods. We also identified that an IPv4 address has 2 major components. There's the network portion, which is like a street name somewhere on the left. And there's also a host portion, also like a house address that's over on the right. And somewhere in all of this, there's a dividing line. Now, my question for you is, do you remember how we control or identify the dividing line between the network portion somewhere here on the left and the host portion somewhere here on the right? Do you recall that? And as we talked about it initially, we identified that it was the mask, this little guy right here, the mask that controlled where that dividing line is. So the first 255 says this whole first number is part of the network. This 255 says the second number is part of the network. This 255 in the third position says this number is part of the network, and the 0 indicates that nothing from the last number is the network, which leaves it as host addressing. So this computer is sitting on the 10.1.0 network, and its host address is .37 on that network. And what I wanted to do is actually show you what's going on behind the scenes with this IP address, because this is represented in decimal numbers. They call it dotted decimal because we're separating these 4 decimal numbers with periods. But behind the scenes, computers love ones and zeros, which is referred to as binary. So I'd like to pull back the curtain and show you how, even though we see a number like this in what's known as dotted decimal, the computer is processing and working with that IP address information in binary. And so to confirm here, we have the configuration regarding a network interface card. We went to properties of that network interface card, and then selected the Internet Protocol version 4 properties, which brought up this pane. And this is where we could go to statically configure or modify the IPv4 information for the network interface card. Also, correspondingly, we could go to a command prompt right here and type in ipconfig, and that could verify what our IP address and mask is, along with the default gateway. Now, this IP address of 10.1.0.37, although we see this as 4 decimal numbers, the computer sees it as a string of 32 bits. Think of a bit like a light switch. It's either on or off. That's it. And that's sometimes why we refer to an IP version 4 address as being 32 bits in length. That's the entire length. Now, as a human, if we have this IP address of 10.1.0.37, and for whatever reason, we wanted to calculate or verify what the binary equivalent was of that number, what we could do is take that number of 10.1.0.37. I'll put the 10 here, the 1 here, the 0, the 37. And this is a way to break down each of those numbers into binary. We simply make this little scale that starts on the right with 1, and you double it. 2, 4, 8, 16, 32, 64, 128. So that's 8 positions in length. And these 8 positions also represent 1 byte of data. 1 byte of data is 8 bits. Another way of referring to these 8 bits is calling it an octet. So 1 byte of data or 1 octet of data or 8 bits of data are all referring to the exact same thing. 8 digits that are either a 0 or a 1 in their respective positions. And if we want to convert the number 10 decimal into binary, all we do is put a 1 in the respective positions. So for 10, we have 1 8, and there's 2 left over, and a 2, and all of these other bit positions would be zeros. So a 10 in decimal is in binary 0 0 0 0 1 0 1 0. And the good news is we get to do this 3 more times. So for the next octet, we have the number 1. So there's no 128s, no 64s, no 32s, no 16s, no 8s, no 4s, no 2, but there's a 1. So the binary equivalent of 1 in decimal is 0 0 0 0 0 0 0 1. And then for the next octet, the next byte, which is a 0 in the IP address, it's all zeros.
And then for the last one, .37, there's no 128s, no 64s. There is 132. So we could do 37 minus 32. We have 5 left over. So there's no 16s. There's no 8s. There's a 4, so we put a 1 there in that position, minus 4. So there's a remainder of 1. So there's no 2s and a 1. So the number 37 in decimal from this guy's IP address is in binary for that last octet, that last byte, 0010101. Another interesting piece is how does the mask operate? The mask is 255 in the first octet, and that's basically a 255 is all ones. 1, 2, 3, 4, 5, 6, 7, 8. Great. And for the second octet, it's 255, which if we did the conversion is all ones. And for the third octet of 255 would be all ones again. And then for the fourth octet, the mask is a 0, which would be all zeros. And here's how the mask operates. The mask is identifying which of the corresponding bits from the IP address is used for the network. So basically you follow the mask all the way until it stops. And when the mask bits no longer are on ones, that's the dividing line. And that's the magic behind the scenes of how the mask is really identifying which portion of an IP address is the network, is where the mask is all ones, and which portion is left over for the actual host addressing. So this would be the network address on the left and the host address portion here on the right, and there's the dividing line because the mask pointed out where that dividing line is. Instead of writing this mask out at 255.255.255.0, another way of expressing this is how many bits going from left to right are currently on in the mask. And there'd be 8 here, plus 8 more, which is 16, plus 8 more, which is 24. So we could also represent the mask as /24, meaning we're using 24 bits, starting on the far left, going 24 bits over and stopping. And that's another way we'll often see masks represented as a slash and then a number, which indicates how many bits from left to right are being used for network information. From that point on, the rest of the IP address is the host portion of the IP address. So at this stage of the game, I do not want you to worry about memorizing the calculations and the conversions and binary and decimal, but I do think it's important to understand some basic terms, including what is an octet? It's 8 bits of data. Those binary bits can be on or off, ones or zeros. And for masks, instead of always seeing them as 255.255, etc., we might see them as a /24 or whatever the length of the mask is based on the IP address. So those are all terms and concepts that are important to know. So I hope this has been informative for you, and I'd like to thank you for viewing.